Children, next we are going to learn about valence bond theory. This theory was given by Hitler and London. They explain the formation of a covalent bond in hydrogen molecule on the basis of wave mechanics of electrons. Further, it was developed by Pauling and Slater. So, based upon them, we can see how the covalent bond is formed between two hydrogen atoms. Consider two hydrogen atoms Ha and Hb. Consider. First, they are separated by infinite distance. First, they are kept far apart, infinite distance. At that stage, there is no interaction between these two atoms. So, the potential energy of the system is zero when the systems are far apart. Secondly, now if these two atoms approach each other, when these atoms approach each other, electrostatic attractive force between the nucleus and the electrons takes place. This is nucleus, this electron. So electrostatic force exists between the nucleus and the electrons. Apart from this, some new forces also appear. Now we are going to see that one. When these two are far apart, infinite distance, there is no interaction between these two atoms and the potential energy is zero. When these atoms approach each other, attractive force between the nucleus and the electrons happens. In addition to that, new attractive forces, that is, number one, the nucleus of Ha and the valence electrons of Hb. This is one of the attractive force. Nucleus of Ha and valence electron of Hb. Number two, nucleus of Hb and valence electron of Ha. Nucleus of Hb and valence electron of Ha. Apart from this, some new repulsive forces also arise. That is, number one, between the nucleus of Ha and Hb, repulsive forces. Nucleus of Ha and Hb, repulsive forces. Between the nucleus of Ha and Hb and between the valence electrons of Ha and Hb. Between the valence electrons of Ha and Hb. So the attractive forces tends to bring the Ha and Hb together, where the repulsive forces push them apart. So at the initial stage, as the two hydrogen atoms approach each other, when they come together each other, the attractive forces are stronger than the repulsive forces and the potential energy get decreased. But a stage is reached where the net attractive forces exactly balanced by the repulsive forces and the potential energy of the system occurs a minimum energy. Now we can see a graph. See, graph. The two hydrogen atoms are in distance, stage 1. So the potential energy get decreased. This is due to the attraction. They come closer. The potential energy get decreased. This is the graph and reaches to a minimum. When the distance become lesser, energy also become lesser and the potential energy reaches to a minimum. At this stage, in this stage, there is maximum overlap between the atomic orbitals of Ha and Hb. So, the atoms Ha and Hb said to be bonded each other by a covalent bond. So in this stage, the internuclear distance between the HH bond is 74 picometer and the liberated energy is 436 kilojoule per mole, and this is known as bond energy. Since the energy is released during the bond formation, the resultant molecule is more stable. If the distance between the two atoms still decreased, repulsive forces, stage 4, repulsive forces dominate the attractive forces and the potential energy get increased. This is the graph. First decreases, reaches to a minimum, then gets increased when the repulsive forces dominate the attractive forces. So based upon this, there are some salient features regarding this. Number 1, half-filled orbitals should be there for overlap. When the half-filled orbitals overlap, only covalent bond is formed. Half-filled orbitals. Number 2, the resultant overlapping orbital occupied by two electrons with opposite spins, one in the clockwise, other in the anti-clockwise. The strength of a covalent bond depends upon the extent of overlap. So, greater the overlap, stronger will be the bond. Greater the overlap, stronger the bond. Fourth point, each atomic orbital has a specific direction. Except s orbital is spherical in shape. Apart from that, p orbital having 3 orientation, x, y, z, d orbital also having 5 orientation. So, in the direction that maximizes the overlap. So, due to overlap, if the two atomic orbitals overlap linearly along the axis, sigma bond is formed. For example, consider 2s orbital, hydrogen atom, that is 1s orbital. If they overlap like this is SS overlapping, head to head overlapping, sigma bond is formed. Similarly, if two p orbitals, for example, take fluorine, atomic number 9, 1s2, 2s2, 2p5, 2p5, p orbital 5, that is px, py, pz, 1, 2, 3, 4, 5. Pz is having 1 electron, so that p orbital double shape 1f, then another fluorine get overlap. This is called sigma bond, pp overlapping. There is also sp overlapping, s orbital of hydrogen and p orbital of fluorine, forming sp overlapping, HF is formed. 1 electron here, 1 electron here, 2 electron. This is sp overlapping. Now regarding one more example I'll teach. Oxygen molecule, atomic number 8, 1s2, 2s2, 2p4, 2px, 2py, 2pz, 1, 2, 3, then starts pairing. These two are unpaired. So, 2 oxygen molecule, similar to px, 2py, 2pz, 2 electron, 1, 1. So, 2py, 2pz. So, here 2pz, 2py. This is for one oxygen. Other oxygen, 2pz, 2py of other oxygen, 2pz, head-on overlap. So, sigma bond. 2py, side-wise overlap. This is called pi bond. Side-wise overlap means pi. Head-to-head overlap means sigma. So, 2py, pi bond is formed. 2pz sigma bond is formed. Everything clearly given in the book, page number 87 and 88.